So pure proof of stake, I want to explain what it means, and I want to convince you that this is indeed a key to decentralization. So we are going to do in 3 steps. First of all, I'd like to frame the problem that I want to solve in as a general way, so that if you're not interested in ledgers, you can still find some use for this talk. And I want to outline, therefore, a problem in its generality, then provide a general approach, and then towards the end says, what has the ledger to do with this, and where does it come into play into the ledger? Okay, so let's start with a general problem. The general problem is keeping a consistent global view. Now, that doesn't sound to be a problem if, for instance, the global view of what? In a database that trusts me. I'm the ultimate authority. You want to know what is written on page 7? Ask me, and I'll tell you. Why is this a global view? Because I promise that if somebody else asks about by page 7, I give the same answer. So this becomes a problem when it's not a central system, but is a decentralized system, is a distributed system. And then even among many honest people, there is a problem. And then keeping this consistent global view is even harder in the presence of adversaries. Some of the components of the system are in bad hands, then things becomes harder. So what is the classical solution? Is a protocol called the Byzantine Agreement. Originally were a bunch of computer scientists, but I understand also that that becomes commonly used in economics in particular. So at the end of the day, a Byzantine Agreement is a communication protocol among a bunch of people, such that if the majority of these people are honest, meaning they follow the protocol, then guarantees 2 main properties. The first property is agreement. The picture shows a bunch of players and hopefully makes clear who is bad and who is evil and who is good in this picture. And we all have a value in our head. And this value may be different, may be the same. But the first property, agreement, means even though we start with totally different values, at the end of a conversation, all honest people should agree on a common value, call it V. Second property, that's not enough, because we want to impose a meaningfulness condition, meaning if all honest people started with this value V, then not only at the end of the conversation we should agree on a common value, but we should agree on the very value we started with. It takes a while to convince ourselves that these 2 properties actually capture what is meant to be by a consistent view in the presence of an adversary. And I want to say these properties must hold no matter what the bad guys can do. So simple tricks say, I want to ask around, what's your value? And then I take the majority, simply fail, because in a situation in which, say, there are 1/3 bad guy, 1/3 good guys start with A, 1/3 good guys starts with B, and the third bad guys tell the first half A, the second half B. These guys count on a 2/3 majority for A, they conclude A. These other guys found a 2/3 majority for B, they conclude B, and therefore we don't guarantee this part, right? That no matter what start with value, we end up with the same value. Okay, so there is some non-triviality in this protocol, but there are solutions. The problem with the general solutions is that they are very slow. Describes slow that the maximum number of players in any practical application so far was 12. That is pretty, not a very distributed system, not a very large system. And moreover, it presupposes that we know beforehand who are the players, and that's a fixed and known in advance set. So over the internet where players come and go is not applicable at all. So that is a general problem. Slow solution, otherwise you would have a solution. Well, what is the general approach? Let me discuss first with magic. And here we go. The magic approach is as follows. 1,000 players are randomly selected among all players, say billions of players. How? By magic. All players, by magic, again, learn the identities of the 1,000 selected players. The selected ones run Byzantine agreement. Now we are few enough to at least inconceivable do something, and they digitally sign the result, the value that they agreed upon, and they disseminate this. And the rest of us agree with the signed opinion of the majority of the committee, because somehow by magic you know where committees are, you trust they've been selected at random, you see the majority of these, which value has the signature of the majority of these players, you go with that. Okay, let's do some sanity check. Sanity check 1, remember the agreement property. If we start with arbitrary values, when we reduce a billion player to say 1,000 players, we get arbitrary values. But these guys, once they run agreement with 1,000 players, they're going to agree on the same value, all honest of them. And right, that is, seems to me that agreement works. Sanity check 2, consistency. If all honest, oops, there are 2 disorders here, but start with the same value, once we do the reduction, but necessarily all honest into this 1,000 players start with the same value, and therefore they will agree on that value. So far, so good. Sanity check 3, Byzantine agreement requires a 2/3 majority. Well, how do you make sure that if you take 1,000 people at random, you get a 2,000 majority? Well, you have to start that you have a little bit more honesty in the general population, and then you apply the laws of probability. Okay, so bottom line, this approach, general approach, passes all the most obvious sanity checks. Congratulations, the magic approach is promising. Well, now it is time to face reality. Forget magic, now we want to use math. By the way, what is magic about it? There is nothing magic about selecting 1,000 players. In fact, I volunteer to flip honestly the coins that I need to select the 1,000 players. Here we go, I flip coins, and the selected players are Daryl, Jing, Chivo, Linda. Are you going to believe me? So there is a problem. How do we solve this problem? The classical solution is that you have the 1 billion players execute some communication protocol among each other, whose output is to 1,000 players who then execute the Byzantine agreement protocol. Really? Of course not, because the trouble it takes me to agree on one value. Agreeing on one value is not so much easier than agree on 1,000 people committee who then agrees on the value. Then what? Then it comes to what I want to describe like the tool, this a general approach tool, I think, that is called, we call it a cryptographic sortition. And what is the answer? To what question do we want to provide cryptographic sortition or wants to provide an answer to? The most natural question is, who chooses the committee? And the idea is that the committee members choose themselves. Now, on a first look at this, that seems a terrible idea, right? Because if there are bad people select themselves all the time, right? That doesn't seem to be working. But what this means is a little bit more subtle. That means that each player runs their own lottery, and this is going to be a cryptographically fair lottery, meaning that even though you are a nation state full of computational power, you cannot improve the odds to be selected by your own lottery. Think of it that you pull down the lever of a slot machine, that you can pull down the lever only once, and 2 outcomes are possible. Either you win or you lose. If you lose, you get nothing. Nobody, you cannot prove to anybody that you are a member of this 1,000 committee. But if you win, then you receive a winning ticket, which is a mathematical proof that you won your own lottery, but you cannot cheat. And so what you do, you propagate your winning ticket, prove it with your member of the committee, and you start talking in the protocol, whatever the protocol is, right? So that essentially is the approach. Let me actually analyze it a little bit. First, I want to make sure that this is super decentralized, because on everybody has a chance of the 1 billion players to be part of this committee. And if they're not part of this committee, maybe we will be part of the next committee. Then this is actually super scalable, because how long does it take me to lower this cryptographic layer of a slot machine? And the answer is 1 microsecond. So in 1 microsecond, I know if I'm a winner or a loser. And if I'm a winner, what do I have to do? Nothing. I have to propagate a very short winning ticket and whatever I want to say. Now, while this is super secure, because if I were a very evil and very powerful individual who can corrupt any 1,000 people on earth I want to corrupt the 1,000 chosen members of the committee. But I have a problem. I don't know whom to corrupt, because the members of the committee are the winners of an inside lottery that you, in a microsecond, you run in your own laptop. I have no idea whom I should corrupt. However, once you go forward and reveal your winning ticket and say whatever you had to say, and you propagate these 2 messages all over the place, then I learn your identity like everybody else, and I can corrupt at that point, but in some sense it's a bit too late, because whatever you said is already virally propagating over the network, and I cannot put it back in a bottle no more than our government can put back in a bottle a message, say, propagated by WikiLeaks. So that essentially is this cryptographic sortition. So what I want you to highlight here, that this way prevents to having 1 billion people to talk to select 1,000 people. Is a magic way to, mathematical way rather, to have 1,000 people select themselves and only the winner shows up. And if somebody wins and wants to shut up, which perhaps is a bad guy, we call it, even better, because if whoever shows up with a winning ticket, there is even a larger honest majority among that. That, in a nutshell, brings whatever we learned in high school or in college about basic probability, the power of sampling, is actually applicable in a very adversarial setting that nobody's trusted to flip coins fairly. All right. What does this to do with the blockchain? All right, what is a blockchain? Is a decentralized database that is readable by anyone, writable by anyone, and inalterable by anyone. That is easy to say, but you cannot walk into a store and ask for a blockchain or 2, no more than you can walk in a store and ask 2 perfect islands, please. I mean, the fact that I name things doesn't mean that they exist, right? So what is the challenge in a blockchain is not preventing an adversary for changing the transaction or the order of the transaction. That is easy. What the real challenge is choosing the next block. Should I choose it or should you choose it? That's the whole hardness. And proof of work, right, which is whatever powers a Bitcoin, has a very interesting idea, is to say, I don't choose the block, you don't choose the block. Rather, there is a cryptographic challenge. Anyone who solves it first posts the solution to the riddle, and the proposed block can has the right to append his or her block to the chain. The end. That sounds very good, except that for power the system to work, the cryptographic riddle becomes harder and harder the more people want to participate. And so when the cost of participation becomes so costly, so I have to have a chance to win once a year a lottery and to win and to solve a riddle before anybody else does, I must have thousands and thousands of supercomputers devoted only to solve cryptographic riddles. The cost is so staggering that the system becomes ultimately centralized. Never mind that it pollutes the earth and so other things. Another popular idea is to say, well, let's simplify the problem. Let's choose, say, 11, 21 people, and let's give them the power to choose the block on behalf of all of us. Wait a minute. At least proof of work ultimately was centralized, but this system is centralized from the get-go, so that's not good. And so there are a lot of other ways to skin the cat, but if you look at these traditional ways, in my opinion at least, there are two main weaknesses, one in logic and one in the consensus protocol. So let's start with the logic. The logic goes like this: the whole economy is secure if the majority of a small piece of ecosystems are honest. Sounds puzzling? Well, sounds puzzling because it's somehow flawed. Because the red big circle is the whole ecosystem, and we rely on the majority of this green dot. And if it is too small, let me magnify it for you. Who is the small dot? In Bitcoin-like systems are the miners. What fraction of the global GDP do the miners represent? You cannot even see with a magnifying glass, you need an electronic microscope. In the delegated proof of stake are the 21 delegates. So to put the whole ecosystem at the mercy of so concentrated few hands is a very big risk. Then there are problems in consensus. So what is the traditional approach? You add a new block to the longest valid chain that you see. Question: and if I see two valid equally long chain, what should I do? Well, you attach your block, choose at random one of the two branches and attack the block to one of them. Okay, what is the meaning of this? You see, when it is your turn to add the block and you attach it to block BI, you are saying implicitly saying to the entire ecosystem, I've looked at block BI and I found it valid. Furthermore, I looked at all preceding blocks and I found them valid too. So I'm voting for the validity of the chain that ends at BI. So assume that is the longest chain you see. If you think that the B3 is invalid, or if you are dishonest and you don't like B3, you attach the block to the previous block, say, to B2. And at this point, by the rule, somebody can attach it to B3 on B4. Let's say they attach it to B4. Assume B3 and B3 prime are both valid, but some bad guy attached it to B3 prime, and somebody else, he attaches to your B3 prime. So B1, B2, B3 prime, B4 is the longest branch that now you must elongate it. And so whatever happens to the shorter branches, that even though they are valid, they will be ignored by the rules and therefore de facto will vanish. And when they vanish, they disappear together with the transaction that they contain. Moral of the story is that this type of approach to consensus, longest chain vote, you cannot rely on a block as soon as it appears. Because if a payment to you appears here, can you ship the good? That is unclear. Because it could be that somehow there is some other longer branch will take over and you disappear. Bingo. So the deeper the block, in other words, the more the block is voted upon, the more probable is that it will continue to stay on the chain. If you believe that there is more block proposers are honest than others. So, but how deep should the block be? 5 deep, 10 deep, who knows? The part is that what's happening here is that the traditional approaches only guarantee eventual consensus. It's a drip, drip, drip process. And you need to wait a long time of accumulation of blocks because you can get some evidence that you are on the longest chain. Okay. Change of scenery, pure proof of stake. The emphasis is on pure. What is it? It's a stronger logic and a stronger notional consensus. The stronger logic is that every token has the same power, and most tokens in honest hands imply that the economy is secure. In other words, who has the chance to disrupt the economy? not a few or the chosen few or a minority, but if all of us, me, Jing, Dylan, Filippo, Linda, Andrea, collude, and we get more colluders until we own the majority of the tokens in the economy, finally, we can ruin the same economy for which we own the majority of it. Is it bulletproof? No, but it's much better than putting the whole economy at the mercy of a very small piece of it. That's all I have to say. And what is the stronger consensus? The stronger consensus is that you agree, Byzantine agree on the latest block before generating the next one. At a very high level, you use cryptographic sortition to select a block proposer, and then you reuse cryptographic sortition to select 1,000 validators who then agree on the block. Why do I do the second step? Because if when I first select at random a block proposer, there is a possibility the block proposer is dishonest and may tell me the block is X, tell you the block is Y, and tell somebody else the block is Z. So that's why we need this agreement with the majority of the signature, etc., etc. And to be technically correct, you don't select people, you don't select accounts, you don't select wallets. What do you select? You actually select tokens themselves. So every essentially wallet is weighted by the lottery according to the amount of tokens that it has. So you may actually be selected twice. In such a case, you have 2 votes in the Byzantine agreement if 2 of your tokens are winning the lottery. So here is the pure proof of stake in action. B1 is the first block, the only block that lacks any ambiguity because it's part of the very definition of any blockchain, any distributed ledger. And on the right, you have a favor, which is intended to mean lightness, a symbol of lightness and effortlessness. And as this favor effortlessly falls to the ground, the chain unfolds in a linear fashion. Well, what happens to proof of work? What happens to fork? Guess what? There is no proof of work because there is only a microsecond to decide and then a few operations to do the Byzantine agreement. And why there are no forks? Because roughly 2/3 agree on one block. There is, honest people, there is no other 2/3 who agree on a different block. So you don't have to worry that a block will disappear. Once it appears, it will stay there. And no proof of work means easy participation. Anybody can participate as long as you can afford a microsecond of computation, you are welcome. And no forks means transaction finality. You don't have to worry about an economy in which a wire transfer for some reason somehow magically disappears, okay? Okay, another day, another talk. Today, I only wanted to carry on one point, but I believe it's an important point. So namely, a very general technique to squeeze 1 billion players to 1,000 players without recrimination, without interaction. In fact, in my opinion, is a significant tool because a 6 order of magnitude savings is significant. In another talk, you have to explain once you have 1,000 players, if 12 was the maximum number of players in a practical Byzantine agreement, well, you have to create a new Byzantine agreement protocol, but somehow that is actually possible. And tell you the truth, you know, there is a need of a fair talk. This blockchain, these distributed ledgers are like an onion, you never finish, and you cry a lot, blood, sweat, and tears when you peel them. But I want to give a more positive takeaway. Complex goals do not have trivial solutions. And in my opinion, at least distributed ledgers are complex goals. But the optimism comes that if there is a will, there is a way. In this particular instance, the way I claim to be pure proof of stake, but 99% of the time, I'm convinced that if we don't surrender, we will find a way. So what can I say? Stick to your dreams and be pure. Yes, Daryl.
This is like the last talk that I saw from you. It's revelatory. Thank you. I'm blown away, but I have a couple of questions.
Please.
In the finance application, if you're, let's say that the blockchain is recording deeds to, let's say, buildings in New York, you really want to be effectively 100% sure that you own the building. You're getting an extremely high probability, let's say 99.99 something %. Are you going to be able to convince the entire real estate community and all the regulators that they don't need to worry about this extremely small probability that you don't actually own the building because something went wrong?
A very good question. So first of all, for this to take off, so we all need to educate each other of what really matters in finance, what really the computer science behind it, and so on and so forth. But I claim that with the proper first, second times of explanation, so we can make this probability smaller than the probability today is raining in Boston that I get out of the house and I get stricken by lightning. Because if I'm worried about this probability, I should never leave the house. So, and I claim that something that has a chance to be seen once in the lifetime of the universe, I don't have to worry about. Because my longevity dreams, but even when I include them, my progeny, kids and grandkids, etc., the age of the universe is a long, long time. So nobody will live long enough to see it. But the trick is to really prove that this is the case, that the numbers are such that the probability is squeezed at a point in which any man on the street is convinced, no, I'm not worried about that an earthquake will crack the earth and I'm going to disappear in hell in the next hour. And that's what matters. So I do claim that as humanity, we have always relied implicitly on probabilities, but I believe that our modern society even more. I mean, because at some point we have to figure out, no matter what we do, if we want to sell a building, so is there going to be an atomic exchange between superpowers right now? I mean, I have to absorb it as in finance this risk too. And the risk we're talking about are less probable, I hope, for sure, than was the risk of a nuclear exchange.
Just a quick follow-up. I like that answer. In finance, maybe you can't trust 1 or 2 or 3 banks, but if you're doing a securities transaction, and let's say you're 21 permissioned banks, permissioning banks, all the top leading securities dealers in the world, they all say this transaction really occurred. That's probably satisfactory for every participant in financial markets. If JP Morgan, Goldman Sachs, Morgan Stanley, Bank of America, and the other 20 all say that I now bought the treasury bonds from you, it's unthinkable that I don't own the treasury bonds. Everyone will trust that. And that might be faster. So in what settings do we not want to trust, let's say, the most trusted 20 in the market?
Well, so first of all, one thing I want to make it clear. The fact that this is mathematically complicated doesn't translate in being slow. I actually believe that everybody should use the public transportation system if it is faster than private transport. So that's where we are doing. So what I'm describing is something which is complex, even though I only exposed one layer. But I make the claim that this is not slower than a traditional system at the end of the day. So that is the thing. More pointed to your question, I agree as an American that a lot of things that go wrong with our first bank. But if I live in Thailand, do I feel the same? If I live in China, if I live in a developing country elsewhere, I may never heard about these banks. So then the equation is that cryptographically, and in the case in a distributed ledger, properly distributed, we want to raise the bar so that our level of comfort is way above trusting our favorite 21 institutions. If we can do it, And the point is that because we could do it, why don't take advantage of it?
Good, thank you. Those are great.
Thanks.
Thanks, Silvio. We have time to take another quick question. Harold, would you like to unmute and ask directly?
Yeah, that's fine. I mean, fascinating talk. So thank you for this. You know, I'm maybe related to Daryl's question in some ways, right? And so suppose a proposer proposes to do some evil thing, right? I think that's where you want to get the selected 1,000 to somehow stand up and say that's wrong or don't append the block here, you know. But what's the incentive for them to do that, right? I mean, suppose I own, you know, some stake in that blockchain. I get selected, but I have better things to do. I want to watch a movie or whatever, and you know, I just quickly click. You know, that's all right. It seems to me that if you have these 20 institutions that Daryl Duffy described, you know, they don't want to be caught in doing something that's really wrong. It will harm their reputation. But if I'm just selected, you know, every few thousand years, you know, why should I care doing the right thing?
Well, let's say orchestrating incentives is much harder than orchestrating an algorithm and even a protocol, which is an algorithm run by multiple people. I agree, because human beings are very complex. And somehow, however, I believe that somehow it is smart not to have incentives at all. Let me explain, because that prevents machinations to exploit the incentive system. So what I believe on is that if being honest, doing the honest thing, I get a reward of 100. And no matter what devious things I do, my reward is 100 plus 0.00001. I might as well be honest, because I don't have to take time to scheme and to read anything else. Right? So that's what happened. Why can we do this? If you look up, contrast pure proof of stake or say against, say, proof of work, if you ask somebody to make a decision, you have to buy thousands of computers, you have to spend the electricity to run them, then to spend extra electricity to refrigerate them because they generate a tremendous amount of heat. Then when participating to this stuff, the cost is so high, I prefer to be a subject of an empire than a citizen of a republic if I have to cut off an entire wood in a year in order to be an honest citizen. It says, well, give me an empire anytime. But if we are talking about that the amount of computation that you run in the background of your laptop, this consensus algorithm that absorbs essentially no power, I might as well run it. Because to orchestrate and change the software and do something else is going to cost me more effort. Let me ask Harold, how many times have you switched off, say, Gmail to save electricity? Never. So if we reduce it to that level, I believe it's easy to be honest. So somehow honesty has been very much, most of the time, requires a big effort and sacrifice and things, and some people are willing to sacrifice, and hat off to them. But when it is actually so damn easy, I may be an optimist, but I believe in what you economists called epsilon utility, that I don't go after epsilons. I might as well be honest and be consistent. Nobody will jail me, nobody will punish, nobody will actually do. But that is the way we do the system.
And Andreas
Thanks.
commented, I think Chivo just commented something. Chivo, why don't you unmute?
I just want to add a little thing, like even if you don't want to, even if you have stakes in the network and you don't want to participate actively in the system, like that, nobody forces you. So if you are the person to say, I don't care, I don't want to do it, you just don't participate to the lottery system itself, even if you have stakes. So like,
yes, correct. But by the way, I believe what Andrea says is correct. And in fact, I wanted to emphasize that when you want to be open, in my opinion, you need that open to the willing and make it easy, but always to the willing. You don't want to drag, now is your time to jury duty, right? And then I compensate you, I give you $100 for the day. I may be an entrepreneur, I run a shop, I have other things to do, I have to be in court. You don't want to grab a reluctant jury member into a courtroom, what justice will you get? So you just say, you know, if you don't honestly declare on the ledger, don't bother me with that. I want to be just a consumer. I trust you guys. But it's okay too. But by the way, but the point is that if I raise my hand, what I have to do? Nothing. A microsecond or computation here and there. So that is not, you know, something that, you know, that's a little bit of the idea. Of course, you know, every model, as we heard today several times, has assumptions, and any assumptions can be questioned. But relative to other assumptions, like proof of work or delegated proof of stake, I find a pure proof of stake more appealing.